Hello students, today we will discuss about the probability function on a random variable and its distribution. Right? The topic is probability distribution of random variable. I have written it to save the time. Please note it. Probability distribution of random variable. First thing we will discuss about probability function. Probability function, right? Probability mass function or probability function of a random variable. We have already seen what is a probability function. Actually, probability is a function, it is a real valued function. It is a real valued function. That means its range, its values will be real numbers, right? And its domain, what is the domain of a probability function? Its domain is the power set of the sample space. We have read it, right? The domain of the probability function is the power set of the sample space, and its codomain is the set of real numbers. That means takes real values, right? Satisfying certain conditions. That means each probability of each event is greater than or equal to 0 but less than 1, and whose summation, the summation of all probabilities of all the outcomes of the sample space is equal to 1, right? Similarly, here we will define the probability function of a random variable. In the last class we have read the random variable. What is a random variable? A random variable is also a real valued function whose domain is the sample space only, the set of sample points, the set of all possible outcomes of your random experiment, right? Yes. So let us define the probability function of the random variable. Random variable is a probability, it is a real valued function. Suppose this was your sample space, and this is the set of real numbers. Your random variable is a real valued function. Real valued function. That means whose range is a subset of the set of real numbers. In function chapter you might have read that the real valued function, the domain may be any set, but its range is a subset of the set of real numbers. That is called a real valued function. Similarly, our random variable is a real valued function whose domain is the sample space and whose range is a subset of the set of real numbers. Suppose say x1, x2, x3 up to xn, right? Now we will define a probability function over this range of x, the values of the random variable. These are the values of the random variable x1, x2, x3 up to xn. Let us define your probability function, right? It is also a real valued function. It is also a real valued function which maps to its range px1, px2, right? Pxn, or simply it can be written as p1, it is p2, it is pn, right? That means the image of x1 is px1 or p1, image of x2 is p2, image of xn is pn, right? This is a probability function defined on the random value. Random variable, the values of the random variable, right? Now, what are the restrictions? You see what is given. S be the sample space of a random experiment, S, and X be a discrete random variable. Discrete. I have told you that in our course, in plus 2 syllabus, we will only discuss about the discrete random variable, not the continuous random variable. So anyway, X be the discrete random variable whose range is x1, x2, x3 up to xn. That means takes the values x1, x2, x3 up to xn. The probability function p of the random variable x is a real valued function. It is a real valued function, I have told you, whose domain is the set x1, x2 up to xn. Right? That means the values of the random variable satisfying the following conditions. Satisfying the following conditions. What are those? The pxi, probability of xi, is always greater than 0 for all I is equal to 1 to n. That means we are assigning, we are allotting some real numbers to these values x1, x2, x3 up to xn in such way that each value of the random variable assigned with a positive real number, positive, not necessarily negative, and 0. No, they are positive real numbers and whose summation is equal to 1. That means p of x1 plus p of x2 up to p of xn. The summation will be equal to 1. Now it satisfies the conditions of a probability function. So this is called a probability function defined on the set of values of the random variable and hence on x. Yes, it maps from the set of values of the random variable to the set of real numbers satisfying these two conditions. Now question may arise, why it is positive in probability space? We know that probability function can take 0 value, may be greater than 0 but less than or equal to 1 always. It is greater than equal to 0 but less than equal to 1. But why it is not 0 here? Why it is not 0? Right? Why it is not equal to 0? Because you see, random variable xi, x1, say x2, x3, xn, whatever value of the random variable you may choose, it is associated with at least one sample point, right? Otherwise these values will never come, because what are these? These are the images, these are the image set of the random variable. What is the domain? Domain is the set of outcomes, sample points, or this sample space. So each of these value of the random variable is associated with at least one sample point. At least one sample point. So impossibility of the occurrence of any one of these values is not possible. No, it will must occur in at least one sample point. Okay, after this we'll take an example where you will be clear how these values are associated with at least one sample point, right? And that is why the probability of these values cannot be 0 anywhere. Cannot be 0 anywhere. So, yes, so it is greater than 0 and whose summation is equal to 1. These two conditions satisfy the conditions of probability. So, this is a probability function defined on the random variable. Probability function of a random variable. And simply it is called probability mass function. It is called probability mass function. Okay. Now What is probability distribution? You see, for different values of the random variable, there are different probabilities. May be same, but each must have a probability, right? So these order pairs, here it is clearly written, the set of order pairs xi, that means x1 px1, x2 px2 up to xn pxn. All the set of values of the random variable together with their probabilities is called the probability distribution. That means, you see, the sum of the probabilities should be equal to 1, right? The purpose is how we will distribute these values to each of the values of the random variable so that their sum is equal to 1, right? And they will satisfy all the conditions of probability function. Okay, so this is the probability distribution of the random variable x, right? Yes. So you see, the random variable is a function from the sample space to the set of real numbers whose range is x1, x2, x3 up to xn, and your probability function is also a real valued function. It is a real function actually. It is not a real valued function. It is a real function because its domain is the subset of the set of real numbers, and its range is also the subset of the set of real numbers. Here, domain of this probability function is x1, x2, x3 up to xn. Xn, and its range is this: probability of x1, probability of x2 up to probability of xn. Okay, so this is your probability distribution of a random variable. Let us take an example, very simple example, so that it will be clear to you. Okay, let us take. Yes, I will wipe out. Suppose you are very much acquainted with the tossing of a coin. Yes, it takes a important role in studying, in reading probability theory. Tossing of it is a very simple experiment to toss a coin. It's a very simple and quite available. At any time we can do it. Practically we can toss a coin, right? So this is a very simple experiment. Let us consider that simple experiment. Yes, example. Let a coin be tossed thrice, right? A coin be tossed thrice. Yes. Okay. What will be the sample space? Yes. What are the possible outcomes? Then the sample space S is equal to, yes, all the cases head. We are tossing the coin thrice. In all the cases, in all the toss, it may head appear, yes, or we may get 2 heads and 1 tail. That is like this. Similarly, we can get 1 head but 2 tails. This is the way in which we can get 2 tails, 1 head, and finally we can get 3 tails. These are the possible outcomes. Yes, first I have taken 3 heads, there is a chance if you toss a coin thrice, then all the time head will occur. So what is the sample point? Head, head, head. And here first 2 toss you may get 2 heads, then tail. Now how you will get 2 heads and 1 tail? The last one make it tail, then move it to the left. Yes, it will be tail, then this. 3 cases, no any other chance. Then 1 head and 2 tail. Good. 1 head and 2 tails. Here, head, tail, 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 head, tail, 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 head. I am moving. First I am taking head and moving one by one to the second position, then to the third position. Mathematically you can do it like this. Then after that no head may occur. That means all the cases will be tail, tail, tail. Right? So this is our sample space. Let us consider the random variable. Let us define a random variable x which represents the number of heads. Number of heads. Then x. Acha, what are the possible outcomes then? Then x of head, head, head is equal to 3. It is 3 because there are 3 heads, and x of h, h, t, that is also equal to x of h, t, h, that is equal to x of t, h, h. It is 2. X of head, t, t, that is x of t, head, t, tail, that is equal to x of tail, tail, head, that is equal to 1. X of t, 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 this is equal to 0. Number of heads, x represents the number of heads. Yes, here it is 0. Okay, so you see 3 heads will occur only once. Here again you see. Yes, we are taking a fair coin. We are taking a fair coin. Fair coin means an ideal coin, a perfect coin. Perfect coin. That means which is not biased. Which is not biased. Biased means influenced. It will not give fair decision. Right? You see, if you will have heads on both the faces, of a coin, then it is a biased coin. If you will throw, only head will fall, head will fall. But our experiment is a statistical experiment where all possible outcomes are known to us, but exact outcome is not known. Either head will fall or tail will fall. It is not known to us. But all possible outcomes, the sample space is known to us. This is a statistical experiment, right? Anyway, so we are taking a fair coin. We are tossing the coin thrice. So here these are the possible outcomes, and all possible outcomes are equally likely. Here, as the coin is unbiased, unbiased coin B, you can write yes, the coin is unbiased each outcome is equally likely, right? There are here cardinality of the sample space. Cardinality of the sample space is perhaps 8. Yes, one event, one coin can be tossed in two different ways. Two coins can be tossed in 2 into 2, that is 4. Three coins, or a coin can be tossed thrice in 2 into 2 into 2 using fundamental principle of counting. A coin can be tossed thrice in how many different ways? 2 into 2 into 2, that is 8. You see, 1, 2, 3, 4, 5, 6, 7, 8, exactly 8. So the cardinality of the sample space is 8. Now, yes. So probability of each outcome is 1 by 8, because their summation should be equal to 1, right? And each outcome is equally likely. So probability of this plus probability of this plus probability of this plus probability of this, like this, its summation should be equal to 8, and all are equal. So probability of each outcome is 1 by 8, obviously. Now we will define, suppose probability of 3. 3 means, what is the probability that you will get 3 heads? Our random variable value is 3. Yes, this is nothing but probability of head. That is, it is one sample point, so it is 1 by 8. Then probability of 2 heads, it is probability of head, tail, head. That is equal to probability of head, tail, plus probability of head, plus probability of tail, head. That is 1 by 8 plus 1 by 8 plus 1 by 8, that is 3 by 8. So probability of 2, the value of the random variable 2 is 3 by 8. Similarly, probability of 1, this is also 3 by 8. You see there are 3 sample points. This. Yes, probability of this plus probability of this plus probability of this is equal to 3 by 8. And what is the probability of 0? It is also probability of tail. That is 1 by 8. So now you see, we have defined such a probability of the values of the random variable which are positive. You see, it is positive, this is positive, this is positive, this is positive, and their summation here pi is greater than 0 for I is equal for all I, right? Then summation of pi, that is probability of 0 plus probability of 3 plus probability of 2 plus probability of 1 plus probability of 0, that is 1 by 8, 3 by 8 plus 3 by 8 plus 1 by 8, that is equal to 8 by 8, that is equal to 1. Sum of the probabilities of the values of the random variable is equal to 1. Thus Pj probability function T function of the random variable right? Again, see the distribution. Yes, distribution, it is the set of order pairs. Which order pairs? The value of the random variable together with its probability. Yes, 3. Its probability is 1 by 8. 2, 3 by 8. 1, 3 by 8. 0, 1 by 8. Is the required probability distribution of the random variable. Right? This is the way in which we have distributed the probability values to the values of the random variable. We have assigned the real numbers to the random variables. For the random variable 3, we have assigned the real number 1 by 8. To the random value of the random variable when 2, we have assigned 3 by 8. To 1, we have also assigned 3 by 8. And to 0, we have assigned 1 by 8. So this is the distribution. This is called the probability distribution of the random variable, right? Very simple. First find out the sample space, then define the random variable perfectly and find its range. Random variable is a function. Which function? It is a real valued function, and find its range. Then assign the probability, assign the real values, real numbers to all these values of the random variable in such way that they are all positive and their sum is equal to 1. Right? Then this assignment will be called the probability function. This assignment of real values to the values of the random variables is called a probability function of the random variable, or simply probability mass function. And this set of order pairs, the values of the random variable together with their probabilities, is called the probability distribution of the random variable. Okay, so now you might have clear about what is a random variable, what are the, how we will get the values of the random variable. Yes, then how can we assign the probability to each value of the random variable, which is called a probability distribution of the random variable. Okay, next time we will discuss about more examples of your NCERT book. So let us stop here and prepare for the next lecture. Okay, thanks.